Good morning to all of you. Today we discuss about the article Moment of Inertia. Okay. As a part of a system of particles and rigid body dynamics, this concept is very important to describe the motion of rigid bodies. Before that one, what is a rigid body? Rigid body is nothing but a body, the inter distance between molecules, that means atoms, doesn't change, even action of external forces. Okay, that kind of body is called what is a rigid body. Okay, we all of you know, when you are allowed to move freely by acting upon by external force, that rigid body undergone translatory motion. What is the translatory motion? The displacement of each and every particle remains the same, which is equal to displacement of whole the body. That is called translatory motion. Okay, it is possible and only you are allowed to move freely. Okay, that means the external force causes two changes in rigid body. What are those two changes? Either it undergone translatory motion in the direction of external force or in the direction of component of direction of external force. Second one is the external force may cause a change in its dimension. That means it change its shape, size, and etc. Okay, but the same rigid body may undergone rotatory motion when it is pivoted or fixed at somewhere. Okay, that means there are two possibilities. Okay, when a rigid body undergone motion, one is whether it is allowed to move freely, it is undergone translatory motion. When it is pivoted or fixed at somewhere, it is undergone rotatory motion. Okay, about a particular point. Okay, that point is called axis of rotation. Okay, you want to describe the rotatory motion of this kind of rigid body. The concept of what is that moment of inertia is very essential. It is very necessary. So with the help of this moment of inertia, you are trying to describe the motion of rigid body. Okay, so here rigid body is undergone what kind of motion? Rotatory motion. Okay, suppose let us take a rigid body. This is a rigid body. Okay, this rigid body is rotate about this axis. About this axis, you know, the total mass of the rigid body is equal what? Capital M. This is the rigid body having different masses. That means different particles. Those are having different masses. They are at different positions from the same axis of rotation. So first particle of mass m1 is at a distance r1. Second particle of mass m2, okay, is at a distance r2. And third particle of mass m3 is at a distance r3. And fourth particle of mass m4 is at a distance r4 from the same axis of rotation. Okay, you know, according to kinetic theory, that means mechanical energy of a particle, every body having two energies. One is called potential and second one is kinetic. Okay, here we discuss about only kinetic. You know what is the kinetic energy formula of a body? Of mv square is nothing but what is a kinetic energy of a rigid body, isn't it? So you want to find kinetic energy of this rigid body. It is nothing but of m1 v1 square plus of m2 v2 square and so on, isn't it? But we know this body, this rigid body is rotate about this axis with angular velocity omega. Okay, that means when a body in rotatory motion, different particles of that rigid body may have different linear velocities, but all are having same angular velocity. So from the relation between linear velocity and angular velocity omega, what is that? V is equal to what? R into omega. That means the linear velocity of a particle of a rigid body undergone rotatory motion is equal to product of its angular velocity and perpendicular distance from the axis of rotation. Okay, right. So when you square on both sides, v square is equal to what? R square omega square. So you can substitute in place of v square by r square omega square. Therefore, kinetic energy of this rigid body is equal to what? Half into m1 into r1 square omega square plus half into m2 into r2 square omega square. Here why I can write omega? Because different particles of the rigid body may have at different linear velocities, but all are having same angular velocity. That's why angular velocity means constant for every particle of this rigid body. So from this I would like to take of omega square is taken as common. So it may write what? m1 r1 square plus m2 r2 square and so on. Okay. In this equation, it may write of omega square into I. So this is the kinetic energy of rotating body. So here I is equal to what? Here I is equal to what? m1 r1 square plus m2 r2 square and so on. So this is the term is called, what I say, moment of inertia. What is that? I is what? Moment of inertia of this rigid body. So the moment of inertia of a rigid body is equal to product of mass of every particle and square of distance. What kind of distance it is? Perpendicular distance from axis of rotation. So the moment of inertia of the whole body is nothing but what is I is equal to 1 to n mi r square. Okay, so this is the kinetic energy of a rotating body compared with the kinetic energy of a translational body of m v square. So in place of I, m is there. In place of v, omega is there. So what kind of role played by the mass in translatory motion? Moment of inertia played the same role in rotatory motion. So moment of inertia is rotational analogous of mass in translatory motion. Okay, right. Okay, therefore the moment of inertia of a rigid body, okay, I is equal to what? M into r square. Here m is the mass of the rigid body and r is the square of the r is the perpendicular distance from the axis of rotation. Okay, so from this definition we come to one conclusion. What is that? The moment of inertia of a rigid body is depends, okay, on two factors. What are those two? One is the distribution of mass of the system of particles and perpendicular distance from the axis of rotation. That means either change in mass or in r, okay, or individually change may causes change in moment of inertia. But in translator motion, only the mass is measure of inertia. But in rotatory motion, moment of inertia not only depend on mass but also perpendicular distance from the axis of rotation. Okay, so analytically the moment of inertia of a rigid body depends. What are those? Mass of the system of particles and perpendicular distance from the axis of rotation. Okay, so this is for discrete system of particles. But in our daily life we come across different kinds of objects. Those objects may have uniform structure, but it is not possible to separate, okay, like discrete particles. So in this case, a continuous, that is called a continuous mass distribution of system, this moment of inertia may be determined by interchange. That means we can extend it, the summation in place of you can introduce the integration in place of, okay, summation. So in case of discrete system of particles, the moment of inertia is equal to, what is that? Integral dm into what? R square. Dm into what? R square. Okay, in between the proper limits. Actually here m is equal to what? Mass. You know, mass is equal to what? Volume into density. What is volume into density? So you should replace mass by volume into density also. Volume into density also. So it may be right like this. I is equal to, it means moment of inertia in terms of volume and density. That is that dv into d into what? R square. Okay. So what is that? Moment of inertia is equal to integral dv into d into r square. Here dv is the change in volume, d is the density, and r is the perpendicular distance from the axis of rotation. So what are the SI unit of this moment of inertia? I is equal to m into r square. M is equal to what? Mass, that means what? Kilogram. R is the meter, so kg meter square is the SI unit. Similarly, what is the CGS unit? Okay, mass in gram. distance is in centimeter square, so gram centimeter square is the unit of moment of inertia in CJ system of unit. So next, what is the dimensional formula? What is the dimensional formula? Mass is represented by capital M, okay, or distance is nothing but what I say, L square. So ml square t power 0 is the dimensional formula of this. Okay, what is it? Dimensional formula of moment of inertia. Now one question is come into the picture. What is that? Whether this moment of inertia is a vector or a scalar. You know what is our consideration? Moment of inertia is played same role as mass in translator motion, isn't it? So mass is scalar. Similarly, moment of inertia is also a scalar quantity. So it is a scalar. It is a scalar quantity. Okay, right. Okay, the next corresponding concept about this moment of inertia is called radius of gyration. Radius of gyration. It is represented by k. Okay, what is this radius of gyration? You know, this is a rigid body. Okay, once again we recall moment of inertia concept. Okay, so this is a rigid body. This is its axis of rotation. That means this rigid body is rotate about this axis. Okay, right. Now, you know, according to previous knowledge, what is that? When you take a rigid body, the total mass of this rigid body is supposed to be concentrated at a particular point. That point is called its center of mass. Isn't what is that? Center of mass. So that point is called P. That means the total mass of this rigid body is supposed to be concentrated at point P. Okay, this point P is at a distance say called K from axis of rotation. So this K, this distance K is called, what is that? Radius of gyration of this rigid body. So the radius of gyration of a rigid body about an axis is equal to the perpendicular distance of point P, which acts as total mass is supposed to be concentrated, that is called its center of mass, and from the axis of rotation. So this perpendicular distance is called what I say, radius of gyration. So recall the definition of moment of inertia. So I is equal to what? M into k square. Here k is called radius of gyration. So from this one you can write k square is equal to what? I by m. That implies k is equal to what? Under root I by m. This is called, what is it? Moment of inertia. What is it? Moment of what is that? Radius of gyration. You know, from the definition, I is equal to what? Sigma I is equal to what? 1 to n mi r square by m means what? Sigma I is equal to 1 to n. What is that? Mi. So this is the mass. That means sum of the individual particle masses is gives rise to total mass of this rigid body. So that the radius of gyration from this you can get only, what is that? Distance from the axis of rotation. Okay, that's it. So moreover, the unit of radius of gyration is nothing but meter. Okay, and its dimension formula is also meter. That means what? M power 0 L t power 0 is the dimension formula of radius of gyration. Its units is equal to what? Meter in SI system. Okay, that's it. And the factors influences the radius of gyration. You know, what is that? It depends only from the axis of rotation. It is depends only from axis of rotation. This is one of the point. Okay. Moreover, the distribution of mass of the axis of rotation is also influences the radius of gyration. But it is not depends on angular velocity, angular frequency, and so on. Okay. If suppose the temperature of this body is supposed to be increases, what happen? Is there any change in temperature in center of mass? No, it is not. No. Yes, it is expands. The center of mass is also changes. So whenever the temperature of this rigid body is increases, what is that? The radius of gyration also, what is that? Increases. Okay, these are the factors influence the radius of gyration of a rigid body. Okay, that's it.